Hello, everyone. Good afternoon, and welcome to today's session, Building a Data Foundation to Fuel Generative AI. My name is Andrew Kutze. I'm a product manager with AWS, and I'm also joined today by a fellow Amazonian, Christoph Barenstein, a director with AWS. And Christoph and I are incredibly excited to be here today to talk to you about the role of your data and how to think about this intersection between your data and generative AI. Now, as many of you already know, generative AI represents a leap in artificial intelligence. And it's capable of generating new content, whether that's text, images, video, or audio, based on patterns in the data that is learned by the underlying foundation models. Now, this generative capability is really transforming how businesses operate today. For example, in healthcare, generative AI is being used to come up with personalized treatment plans by analyzing patient data, as well as to summarize progress notes, which is driving a bunch of internal productivity gains for clinical providers. In the automotive industry, it's driving innovation in design and engineering by coming up with new concepts. Now, that list goes on and on, all the way to generating new music and artwork, and as a product manager, personally, one of my favorites, performing financial data analyses. Now, these things all really push the boundaries of creativity. And the thing that underpins all these generative AI applications are the foundation models, which are trained on massive volumes of data, and they're there to solve a wide array of generalized tasks. Now, these foundation models, and particularly the large language models, the LLMs, are trained on internet-scale web page data from sources like Common Crawl. And then what customers want to do is they want to take their smaller, proprietary data sets that others lack access to, and they want to customize these models for tasks that are specific to their business, like building a travel assistant. And they think about customization in a few different ways, from injecting new or up-to-date information into the context of the prompt, or actually tuning the tone, style, or voice of the responses that you're getting back from the foundation models. Now, I've talked with a lot of customers, and I think it's safe to say that everyone really acknowledges the power of generative AI, and they're very comfortable outlining the visions that they have for their organization. But the interesting thing is that a lot of folks speak with the focus on the foundation models. And while that's important, it's really just the tip of the iceberg. There is so much going on under the surface of every single generative AI application, and much of that is data related. Now, generative AI applications, they're still just applications, and you should be thinking about them as simply a new application type that sits on top of an existing data foundation. This is super important. What you don't want to do is to create a new data architecture, new data strategy to work with generative AI. And so what that means is that when you want to take advantage of what you've already built to store and to use your data for other applications or operations within your business, like analytics and anomaly detection, and just have your generative AI application follow the same rules of the enterprise for data access, governance, and compliance. And so in the end, it's really the data processes that you want to nail down effectively, and that is the focus of our conversation today. Now, every modern business is a data business, and having a modern data architecture is going to help you innovate faster. According to a recent McKinsey report, companies that have not yet found ways to provide ready access to their data are going to be unable to fine-tune generative AI to unlock more of its potentially transformative use cases. And so what this requires is a clear data and infrastructure strategy. But let me ask you this. Why does data matter so much? Well, when you want to build generative AI applications that are unique to your business, your organization's data is your differentiator. Now, every organization out there, they have their own valuable data, and this is the data that differentiates their generative AI applications from the generic generative AI applications that all access the same underlying foundation models. But this doesn't mean that you have to go out and train a new model from scratch. While some companies will certainly train their own large language models and other foundation models, many more are going to use their organizational data to fine-tune these foundation models for their unique business needs, or they're going to add context with an approach that's called retrieval augmented generation, or RAG. Now let's walk through a few examples here to really ground ourselves in how generative AI is helping customers. Now, if you're an online travel agency that wants to generate personalized travel plans, you're going to want to use your customer profile data and provide tailored recommendations based on things like past trips and travel preferences. And then you're going to want to marry that information with things like hotel and flight inventory, as well as any ongoing promotions. Now, I think we've all seen the very powerful capabilities of generative AI to actually create new content. But to make that content relevant and contextualized to your organization, you're probably going to want to customize it with things like your brand guidebooks and previous advertising that you know has been effective, as well as data from your data lake, like your real-time inventory, so that you're showing ads for the right products. Finally, conversational search can be improved when we collect internal data from a variety of different sources, like SharePoint, your internal guides, and Slack, so you're providing more relevant answers. Now, this is actually a very, very popular use case where generative AI is helping customers discover information that's stored within the vast amounts of content that's spread across their company, like the research reports, the brand guidebooks, and the travel policies. Now, one of the questions that I often hear from customers is, should I use an existing foundation model or should I train a new model? And more often than not, my answer is going to be to use an existing foundation model because they're just so capable in their generalized knowledge and reasoning capabilities. But we also know that customers want to try out different models to see what works best for their use case. Some models are really great at text summarization, others are really good at integration and reasoning, and then others have really neat language support. Now, there's no single optimized model for every single task, and for any particular use case, customers are often going to use several different models that work well with each other. Now, there's a few techniques that you can use to customize these foundation models securely with your own proprietary data. This is retrieval augmented generation, fine-tuning, and continued pre-training. Now, these are ranked from the left to the right by what is easiest to what is most complex, while maximizing the degree of customization. At the end of the day, it's up to you to decide which of these techniques is best for your use case. Now, let's go through each of these in a little bit more detail, beginning with retrieval augmented generation, or RAG. Now, RAG is a really great technique if you want to supplement your prompts with new or more up-to-date information. And you want to think about this as information, as data that the initial pre-trained models were not exposed to. Now, it lets the model customize the responses by augmenting your prompt with external data from a variety of different sources, like your document repository stored in Amazon S3 or your databases. And it helps the model adjust the output with data that's retrieved from these knowledge libraries, so that your generative AI applications are delivering more accurate, relevant, and contextualized responses. So what RAG is doing is it's adding information into the context of the user's request to actually bias the model's response without changing the underlying model itself. It's just one of many examples here. Let's say you want to ask about sales or product inventory from last week, or which advertising campaigns were effective. Now, a RAG-based system can incorporate that knowledge into the model's response. Now, it's a really good technique, again, if you want to include relevant facts from an external knowledge source, like a file in Amazon S3, to really ground the foundation model in the most relevant information. Now, let's also say that you have data that changes frequently, like a product catalog that contains inventory and prices, or weather pattern data. You're probably not going to want to go down the route of changing, fine-tuning your model every single time your data changes, which would be quite often for something like weather pattern data. And so with this technique, RAG, you're not retraining the underlying foundation models. Now let's go ahead here and show another use case in action. We're going to go and demo a conversational chatbot, which is used by an insurance company to generate insurance coverage quotes for its users. Now, as we go through the exchange of prompts here, we're identifying what we call situational context. And that is to mean, who is a user, what kind of car do they drive, where do they live, are there additional drivers in the family, and more. Now, all this information is then augmented when we query the insurance marketplace to retrieve competitive quotes for the required coverage. Next, let's go through a data flow of this exact demo. Now, as you can imagine, there are a few things that are happening behind the scenes. First, the user submits a question or a statement, and this is the prompt. Then the relevant keywords are extracted from that prompt and are used to retrieve the similar data from the enterprise datasets. Now, this additional data is then augmented the original user prompt and is submitted to the large language model, which now responds with more relevant and contextual responses. Now, this data that provides this really important semantic context is stored as vector embeddings in a vector database. Now, vector embeddings are just numerical representations of your data that contain the semantic or contextual meaning of text. And they capture the semantic relationships between words within a phrase, a sentence, a large body of text, rather than relying on a simple dictionary definition. Now, that semantic awareness is really important because it lets the model discern whether the word bill in a given context refers to a proposed legislation or a payment that is owed. So the process here, again, involves ingesting this data from the source, splitting it into chunks, converting it into vectors, and storing it in a vector database. Then, during the R and RAG, the retrieval, you're going to do similarity search to retrieve information that is close together in this high-dimensional vector space. Let's go ahead and visualize this. You'll notice that what we're doing is we're simply converting text, and we're representing it as numbers. And by doing this, we can more easily find relationships between similar words and phrases, which really help the generative AI application produce more relevant responses from the prompts that you're getting from your end users. Now, let's show a little bit more of a specific example here. An end user submits a prompt looking for bright color golf shoes. On the left, without the vector embeddings, we're just doing a standard search against the label data for the images or the raw text and the product descriptions. On the right, we're actually capturing the meaning of the prompt, and it's pretty clear that this is yielding more relevant and better responses. Now, let's go ahead and take a step back and go to a 30,000-foot view of what a RAG architecture actually looks like. Now, there's a few components here that you've seen, but the really interesting thing is what kind of data processing and data storage solutions to use. And you'll notice that there's effectively two sides to the story. On the left are all of the processes that happen when the end user is interacting with the generative AI application and is waiting for the response. On the right are all the processes that happen behind the scenes, streaming the data updates, doing all the batch data processing, and all of the ingestion work. Now, you may be wondering how retrieval augmented generation actually fits in. Well, RAG is a pipeline that delivers a semantic context to the interaction. And so let's take a closer look here at the end user critical path. The flow, it looks something like this. The user asks the question, again, the prompt. The generative AI application gets the conversation history and determines the situational context. The user, the address, the type of car, and a little bit more. Then it tokenizes the prompt, and it creates something called the question embedding. It retrieves data that's similar to this target question through similarity search. It invokes a large language model with the engineered prompt, and then returns the response back to the user. Now, at AWS, we know that developers want choice. And to support your vector search requirements, you have a number of options to choose from. For example, you can use Amazon OpenSearch, which supports semantic search by combining vector and full-text search into a single query. Now, if you're already using Postgres in RDS or in Aurora, you can simply just use the PG Vector plugin. Now, this is a really good option if you've already invested into relational databases and you just want the ability to join your vector data with traditional table data in a single query. Or you can use the vector capabilities of Amazon Neptune, our managed graph database service, or Amazon MemoryDB, our in-memory Redis-compatible data store. Now again, our goal here is to provide choice so that you can use your preferred technology for this pretty important part of your AI system. Now, all of the building blocks of generative AI are powered by data. It's your data. It's data that needs to be unionized and intersected to get to a meaningful state. And it's data that is best valued when consumed fresh, at real time, and with really high confidence in its quality. And so to bring this all together, fully integrated and well-governed, means that you need a comprehensive data architecture that's collecting the data, preparing it, and then feeding it into your generative AI application. And so you first ingest and process your data, either in streams or in bulks, depending on your data freshness requirements. Now, this curated data is also used to create a feedback loop with the building blocks that manage all the conversation state and the history of the generative AI application. This curated data is also integrated with your data lakes to provide situational or that transactional context, and then with your vector data stores to provide that semantic context that we were just talking about. Lastly, end-to-end data integration and governance are really critical for your data architecture to be able to securely scale it. Now, for a moment here, let's dive into the ingestion and the processing bits. Now, I've said this before, but when you build on your existing infrastructure, you want to use the data pipelines that you already have in place today. Now, many customers that are building generative AI applications are using AWS streaming technologies like Amazon Managed Streaming for Apache Kafka, Managed Apache Flink, and Amazon Kinesis to ingest data in real time. Now, Amazon Kinesis Data Streams is a real-time streaming service that lets you rapidly move data off of your producers. It's serverless, and it provides both short and long-term data retention options. You can also quickly spin up an Amazon EMR cluster and run with those big data frameworks like Hive or Spark, which are pretty popular for those data preparation tasks.
Well, thanks, Andrew. Hey, folks. My name is Christoph Bartenstein. I'm a director here in AWS, and very happy to talk a little bit more about the data architecture that fuels into GenAI. Now, I'm talking for the last 10 years or so with customers, with Amazon customers about, like, what's about the data architecture? What's about the data strategy? And more recently, we really spent a lot of time about thinking, what data architecture do you need that really fuels GenAI applications? So I want to dive a little bit into that. Now, we talked about RAG, right? So Andrew talked about RAG, what are the pros and cons. Now, there are many other techniques out there. RAG might be one of the easiest ones to get started. I want to talk about two other ones, fine-tuning and continuous pre-training. There's another one, prompt engineering. If you want to hear more about that, there's another session, I think later on in the afternoon, so stick around to do a deep dive there. Now, what's about fine-tuning? So fine-tuning, you can really think about, you give the model labeled data. So what does it mean? Well, labeled data in this context is oftentimes a question and answer pair, right? So you give the model a question and answer pair to really customize your GenAI application. Now, let me give you an example what this question and answer pair could mean. It's oftentimes a desired output based on a given input. So for example, if you think about call center records, you want to optimize the summary for call center records. What you might want to do is you want to feed the model with a summary of examples of those calls, right? So have a call as an input, have the summary of that call as an output. That's a labeled data set. And that really improves your GenAI application ultimately when you fine-tune. Now, fine-tune is a little bit different than RAGs. For RAG, we talked about a vector database, right? For fine-tuning, you don't need that because the contextual semantic is already in your model. So it's really about like making sure you're improving the knowledge base of your model, you customize the model based on the data, based on your enterprise data and your very specific domain knowledge. Now, what's interesting about fine-tuning is you cannot only specialize the content, right? So content is one thing. You might want to also specialize the tone, the style, and that is all possible with fine-tuning. Again, it works by having high-quality data sets, high-quality labeled data sets, and they will impact the model. So not only content, but also voice, tone, and style. Now, one thing to call out, and I talk with quite a bit of customers about that, the model ultimately is only as good as data. So what's happening here, you spend a lot of time on the high quality of the data, and that takes time. So that's about fine-tuning. Another technique is continuous pre-training. So for continuous pre-training, what you're doing is you're feeding the model with high volumes of data, high quality data, but not labeled one. So it's unlabeled data. So think about when you're a financial industry company, you want to feed the model with financial records of different companies, with market data, with newest market data, but it doesn't need to be labeled, it can be unlabeled. The important thing, it's large volumes of high quality data. And what you're essentially doing, you're picking up where the pre-trained model left off. Now, we talked a little bit about that now, so I want to give you some examples later on and how this is all working. Before we do that though, what all those techniques have in common, you still need to think about the process of ingesting, of storing, of cleaning up data. We talked about high quality, that's really important. There are subtle nuances between those techniques. So we talked about fine-tuning doesn't need a vector database, but it's labeled data. It's labeled high-quality data. Continuous pre-training is not about labeling data. It's about the volume of the data and talking about that it's very customized and specific. So improving the knowledge base, improving the customization, therefore. Now, one other call-out Andrew mentioned, so I want to talk about it here in this context. When you customize foundational models, you need significantly less data when you start the model from scratch. And so the slide behind me shows you this. So you see it starts with prompt engineering, goes over to RAG, goes to fine-tuning, goes to pre-training, continuously pre-training, and then eventually you can customize best when you build your model from scratch. Now, the degree of customization is increasing, right? From the left to the right. However, it takes a lot of time, it's complex, and the cost increase too. So one of the things when we talk with customers that stands out, more often than not, you might want to not start with a new model from scratch. More often than not, you start with existing foundational models, you're updating them, you're customizing them, and see how that is going. Now, that was a little bit about the different techniques. So customers want to then know, how do you bridge from your data architecture into your GenAI application? And how do you make sure you can scale and build your GenAI application? Well, let's talk about Amazon Bedrock just very briefly. And Amazon Bedrock is really the easiest way to build and scale your GenAI applications. What's super cool about Bedrock is you have a very broad choice of foundational models. Andrew talked about that. So you have all those foundational models out there, they're specialized in different fields, and you can feed them into Bedrock. So you can connect to different foundational models. Now, Bedrock is also rapidly changing. So let me ask you this, who in the room has used Bedrock before? Raise your hand. Okay, well, just try it out. Yesterday we just launched a bunch of new features. One really cool one is now, in addition to the foundational models, you can also bring your own model, meaning you bring your own model to Bedrock to, again, customize it more. So it's a really easy way to bring your business context quickly, easily, and safely. And the other thing is, Bedrock is built from day one in a very secure way. So that is really built in how we're thinking about it. Now, all the techniques I talked before about, from prompt engineering to RAG to fine-tuning to continuous pre-training, all of those techniques are possible in Bedrock. Now, let's talk about one feature which is very powerful when you think about RAG, which are knowledge bases. So knowledge base is really like a fully managed way to improve your RAG workflow. So what does it do? Well, it allows you to connect to a variety of data sources. It allows you to connect to data sources very easily in a secure way. And that really simplifies your RAG workflow. How it is doing, what you're doing is, in your knowledge base, you connect to a variety of enterprise data, and you can do that by essentially connecting to the source. So for example, if your data is in Amazon S3, you connect to your Amazon S3 bucket. And what Bedrock is then doing, it fetches the data, it creates embeddings, it stores embeddings. And when you then do inference, it takes those embeddings again and optimizes your prompts. Now, one really important call out, and Andrew will talk about it later, while optimizing the prompts, we're also adding tags. And that allows you later on to think about how you want to govern your data, because now you have insights into who is using your models, why are they using it, what is it used for. So this tagging is really important. Let's talk about vector databases for a moment. We talked about the choice of foundational models, and that's really important. Now, the other choice you have is you can use different vector databases, from Open Research to Pinecone to Aurora, and so on. So again, it is your choice. Whatever you want to use, you can do that. You can choose the foundational model, you can choose the vector database, and you can just get started that way. Well, we talked a little bit about the theory, so let's get started. One simple example is behind me. I like wine. Well, it works with juice as well, or whatever your favorite drink is. You have a very simple table behind me. You can store it in a CSV file. And you can see here, it's the name of the wine, it's the price, it's the inventory, and it's an ideal pairing, right? Now, what I did here is I just started in Bedrock a RAG model. What you do is you store the CSV file in an S3 bucket. So pick an S3 bucket, store the ISV file, name your knowledge base, then think about your IAM permissions, so who has access to that file. And then you're creating embeddings, or Bedrock is creating embeddings. You choose the vector database, and that's really it. So at that point, you have your knowledge base, you have your underlying data, you refresh your data sources, and you can get started to ask the model questions. So you can ask the model questions like, how much is a wine? What's the ideal pairing? What's happening if I don't have a certain inventory? And I realized this is a very simple example. It is very simple data. It's one connection. It's one embedding. However, the point is, it's very easy to get started. And it's quite a lot of fun. So if you haven't tried it, I would just suggest try it out. It works very well. Now, talking about having your data in Amazon S3. When we talk with customers about that, oftentimes they have a lot of data in S3. So let's talk about that for a moment. So when you have your data in S3, you're already far along because you already thought about, what's the right security of your data, durability, availability, performance, cost, and so on. And what that means is oftentimes customers who have the data on S3, they already have high quality data. They're already using the data in a high quality way. And so the question now is, how can you bridge the data into your GenAI application? Now, one of the tools, and I want to briefly talk about, is Amazon S3 Lens. So S3 Lens is a tool, is a feature in S3, and it allows you to get this organization-wide overview of your data. So there's a nice dashboard in your console. You can customize it. You can see across your hundreds of accounts, where's your data, what's going on with your data. And then what you can do is you can drill down. You can go down in a bucket, in a prefix, in a tag, in a region, and see what is going on with your data. So this is an example here, right? So you have an overview. You see how much data you have, how many objects you have, and so on. Now, one of the neat features we just recently launched 3 months ago is about having storage lens groups. And what it allows you is you can customize, you can group together your data based on characteristics. So for example, based on the age of an object or based on a certain file format. And that's fairly powerful because now what you can do, you can think about the file format across your petabytes of data, group it together, and point your models to the bucket where that data is. So for example, we have a customer, they have a lot of PDF data, they work with some of that PDF data, they want to figure out, where is my data, where is it stored, they have an age group, they have a group together with the PDF as a file format. Now they know where those data points are stored. They can point the Bedrock knowledge base to that bucket and get going. So it's a very simple way to really get insights into your data. And one of the things with Lens you will see is we keep innovating there, and the idea is really to bridge your data architecture to your GenAI applications. Now, when we talk about bridging that, that certainly goes beyond S3. That is true for all of AWS. Because customers, and we say this over and over again, but it's a really important point, they don't want to create a new data architecture. They don't want to think about a new data strategy. They want to think about a new GenAI application. And so in order to do that, you need to think about all those various types of data. We talked about labeled data, unlabeled data, vector databases, and so on. And you need to think about a place where you have this in a secure way, where you think about the life cycle of your data. And AWS is an excellent way because it's comprehensive, it's integrated, and it's governed. And we talk about the governance piece in a moment. Now, AWS also provides the tools to account for the volume, the scale, and the variety of data. When you think about stuff like storing data, querying data, analyzing data, or putting data to work. Because all that is what you need when you think about this 360-degree view you want on your data. In addition to that, AWS allows you to connect data, so you don't want to have data silos. Within AWS, you want to eliminate ETL. Outside, you want to connect to external data sources. And that means you get like this 360-degree view of your data, of your domain-specific stuff, to improve your application. Because ultimately, as we said, the model is only as good as your data. Now, you want to connect to your data, which is great, but you also want to make sure you know what's going on with your data source, and we know how to have data, who is using data. You want to use the existing services you have, and you can easily extend all existing AWS services into your AI system. So for example, you can use AWS Glue Data Catalog for data cataloging. You can think about data lake formation, about fine-grained access controls. Or you can use IAM for like the IAM permissions. An important piece about logging and thinking about the governance is something Andrew will talk more about.
Thank you, Christoph. Now, we all know that this whole generative AI space is moving so dang quickly. And so it's really important that you look around corners and become your own best auditor. And you should do this now in a way that is fully automated as you continue to scale your AI system. Now, to be your own best auditor, you want to make sure that you're storing your data sets using the same access and security model that you already have in place today for your existing data architecture, and that you're logging how those data sets are being used. As an example here, any prompt response needs to reflect user permissions to the underlying data. Now, this is really, really important. The user that is making the request should only have access to the data that they're allowed to see, which means that the generated response from the model should be based on that permissioned access. So as another example here, for RAG use cases, you can rely on the existing user-level permissions and fine-grained access controls of the vector embeddings and vector databases like Amazon OpenSearch. Now, today, customers use a variety of different AWS services to govern and to monitor the usage of their data, and that is very easily extended into the AI system. Now, if you're using AWS managed services for generative AI, you have the capabilities of data transparency built right in. Now, we launch our generative AI capabilities with CloudTrail support because we know how important, how critical it is for customers to have an audit trail for their systems and their businesses. Now, as an example here, Bedrock has over 80 CloudTrail events that you can use to audit the use of foundation models. And if you want to know what the actual prompts are to these foundation models, you can turn on something called model invocation logging in Amazon Bedrock, which is going to record the input and the output of the invoke model call, so the prompts and then the generated responses back from the model. Using CloudTrail, you can see who invoked the model and when the model was invoked. And if you've customized the model with your own training data set for fine-tuning or continued pre-training, you can see the S3 location of that data set. And so with CloudTrail data events for S3, you can see who else is using that exact same data set to customize other models. And so what this gives you is full transparency into how often a particular data set is being used across your entire organization. Now, as we wrap up today, I do just want to say thank you and leave you with a few resources to go even deeper on this topic. If you need peer-level executive guidance, then our data strategy team of former CXOs is here to help. If you need help building a data strategy, our AWS data-driven everything program will partner with you to jumpstart your own data flywheel. And if you need help migrating and modernizing your architecture, Reimagine Data can define the data strategy for a future data foundation. Now, even though we're reaching the end of our session today, we're just at the start of our journey with generative AI and really putting our data to work. Skillbuilder.aws, the link in the top left here, has a bunch of really awesome online resources that you can use to learn at your own pace, learn what you want and when you want to. There's 600+ free online digital courses, hands-on labs, and a bunch of role-based games. Now, I like to say that technology is what makes innovation possible, but it's the people that will build a better tomorrow. Thank you, and we'll go ahead and answer any questions off stage right here. Thank you.